Then we have oxidation of, so now we've been through addition and we've been through the substitution. Our third one was oxidation. So oxidation is redox. We're thinking about redox here. So take a step back in time, we're going through redox. We just went through electrolysis. So we're back on the topic, talking about oxidation reactions. So oxidation reactions occur in primary and secondary alkanols. So primary and secondary alkanols, they form ketones, aldehydes, and carboxylic acids. So oxidation, remember that oxidation involves the loss of electrons. Well, it also means the gain of oxygen and the loss of hydrogen. So this requires a really strong acidic catalyst. Really important. What are these catalysts? If I'm going through oxidation, these are going to be oxidants. So this is an oxidant and this is an oxidant. Really important to understand. So given you have these oxidants, this is what happens. If I've got a primary alcohol, I go from an alcohol to an aldehyde and pretty much instantaneously go to a carboxylic acid. This step sometimes is just skipped. VCE will sometimes just skip this step. So be aware that sometimes you will go from this to this. It'll be very obvious when they are skipping a step. Like, it's very obvious, but make sure you are aware that sometimes they will just skip the aldehyde. Why? Because the aldehyde is very commonly it's very commonly when you do this reaction in real life, it's very quickly goes from an aldehyde to a carboxylic acid. It doesn't really stay as an aldehyde for very long, so it's not really a useful thing to think about. But nonetheless, this is the first step. It does form an aldehyde first, and then it forms the carboxylic acid. But be aware sometimes this step is skipped. Now, really important. You can use either of these. Doesn't matter which one you use. You're welcome to just remember which one you want. I tend to use dichromate. I find dichromate the easiest to remember. Really importantly, secondary alcohols, they form ketones. Now, they do not form carboxylic acids. Why is that? Because it's not possible to add another bond here to do an OH. It's not possible. It's already saturated in its bonds. It cannot drop a hydrogen. There's no hydrogen to drop. So therefore, it's not possible. So this just goes to a ketone. This doesn't go any further than a ketone. So this is purely just a ketone. It doesn't go any further. So therefore, it's really important to understand that you're not going to get any further than a ketone here. You're only going to get to a ketone. So as you can see here, you get primary to your secondary. You get your primary all the way through to your carboxylic acid, but secondary only goes to a ketone. So primary goes to an aldehyde, then to a carboxylic acid. Secondary only goes to a ketone. Important stuff to remember. So here is a question here. It says here, what is the systematic name for the product of the following reaction? So as you can see here, we've got a primary, and all of these answers are oic acids. So we are skipping the aldehyde. We're not worried about the aldehyde. We are skipping the aldehyde. So have a go at this question. Tell me what you think the answer is. 3, 2, 1. Pause. And hopefully you are back. Hopefully you had time to answer that question and you sort of knew what was going on. So have a go at this. Oh no, you've already had a go at it. Don't know why I said that. All right, so in this question, you have an alcohol group here. Now this alcohol group is going to form, actually I don't think that's probably a silly way of doing it. Let's just get rid of that. This alcohol group is going to form, let's get rid of one of those. And then let's go, actually I need both of those gone. Double bonded to an oxygen. So that's what it's going to become. It's going to become an oic acid. It's still going to be 1, 2, 3, 4. It's still going to be bute. So it's still going to be 4 long. It's not going to be pent. So neither of these. So it's going to be bute, 4 long. The oic acid is going to be the highest priority. So this is going to be 1. It's always going to be the highest priority. Then this becomes 2. This becomes 3. This methyl group is now on the 3rd carbon. So the answer here is going to be D, because it's going to be 3-methyl-butanoic acid. It doesn't help the answer, but nonetheless. 3-methyl-butanoic acid, because you're numbering from the carboxylic acid end, and that is going to be carbon number 1, carbon number 2, carbon number 3, carbon number 4. There's 4 carbons. It's a bute rather than a pent, so that's how I wrote out A and B, and it's going to be 3-methyl.